Hi students, today we are going to discuss about D2A and A to D interface. Before getting to the interface, we have to know about what is A to D converter. That is, the function of A to D converter is to produce a digital word with respect to the magnitude of some analog voltage or current. So the specification for an A to D converter is very similar to the D2A converter. Here the resolution of A to D converter refers to the number of bits in the output binary word, and 8-bit converter is, for example, it has a resolution of 1 part is in 256. Okay, and the accuracy and linearity specification have same meaning for an A to D converter as they do for D2A converter. Another important specification for ADC in its conversion time is the time takes the converter to produce a valid output binary codes for an applied input voltage. When we refer to a converter as a high speed, it has a short conversion time. The analog to digital converter is treated as an input device by microprocessor. Then it sends an initializing signal to ADC to start the analog to digital data conversion. So here the start of conversion signal is a pulse for a specific duration. The process of analog to digital conversion is slow process, and the microprocessor has to wait for a digital data till the conversion is over. So after the conversion is over, the ADC sends an end of conversion. Okay, so in this end of conversion signal to inform the microprocessor that conversion is over and the result is ready at the output buffer of the ADC. So these task of issuing an SOC to the ADC and reading the EOC signal from the ADC and reading the digital output of ADC are carried out by the CPU using 8255 IO ports, and the time taken by the ADC from an active edge of SOC pulse till the active edge of EOC signal. This is said to be a conversion delay of ADC. So next we can say what it may range anywhere from a few microseconds. Okay, and a number of ADCs are available in the market. The selection of ADC for a particular application should be done. So here we see about ADC 0808 or 0809. So the analog to digital converter chip is 8-bit CMOS type, and it's about a successive approximation converter. It is the fastest technique. Okay, the conversion delay is 100 microsecond at the clock frequency of 640 kilohertz. Okay, and let's see about the general algorithm of ADC interfacing contains the following step. It has to ensure the stability of analog input applied to the ADC, and it has to issue the start of conversion pulse to the ADC, and next is it has to read the end of conversion signals to mark the end of conversion process, and the last one is read the digital data output of the ADC, which is equivalent to the digital output. Okay, and let us see about the block diagram of ADC. So the converter internally has 3:8 analog multiplexer, so that at a time it takes 8 different analog inputs can be connected to the chips. Out of these 8 inputs, only one can be selected for conversion by using 3 address lines. And next is this is the pin diagram of ADC 0809. So where here CLK is the clock and VCC is the power supply and ground, and where DB0 to DB7 is your data inputs, and the ABC is your address, and 012 is your analog input, 0 to 7 is your analog inputs, where the 6 pin is connected to start of operation SOC and EOC. And in this table, if we'll see the analog input selection. If P0 is equal to 000, and what is the input selection will be on P1, P2 and till P7. Okay, so this is your analog input selection, and next is your interfacing an ADC, interfacing between an ADC to a microprocessor is a problem. Interfacing an ADC with 0808 with 8086 using 8255 ports. Use port A of 8255 for transferring the digital data output of ADC to the CPU, and for port C for a control signal. Assume that an analog input is present in P2 of ADC and the clock input of the suitable frequency is available for ADC. So here they ask to draw a schematic and timing diagram of different signal of ADC 0808. So the solution for this is the analog input of P2 is used, therefore the address pin is ABC should be 0, 1, 0 respectively to select the P2. So it is will be in your analog table. So the output latch and the ALE pins are already kept at 5 volt and which enables the output, where the port C upper act as an input port to receive the EOC signal, whereas port C lowers acts as an output port to send SOC to ADC. So port A acts as an 8-bit input data port to receive the digital output from the ADC. So this is the overall interface of ADC. So after the conversion process is over, the ADC sends an end of conversion to inform the microprocessor that conversion is over. So these tasks of issuing an SOC pulse to the ADC and reading the EOC signal from the ADC and reading the digital output of ADC are carried out by CPU using 8255 input output port. So the availability of ADC in the market uses different conversion techniques, but the technique what we use here is recursive approximation technique. Okay, and these chips do not contain any internal sample and hold circuit, and it is extremely connected to each analog inputs. Okay, so there are a few in the program about 8255 control word, where here move A, 98H is initializing 8255 to send analog to control alt. And let's see about this program in detail to the next class. Thank you.